Jordan and Israel signed an agreement on the 26th of February to go ahead with a World Bank-sponsored project to build a desalination plant in the Gulf of Aqaba and a pipeline linking the Red Sea with the Dead Sea. The plant will be built in the southern Jordanian port of Aqaba on the Red Sea and will desalinate water to be shared by Israelis and Palestinians. The brine that's a byproduct of the process will be sent north in a 180-kilometre pipeline to the Dead Sea. The project will cost around $900 million. It will take nearly 3 years to complete. Jordanian officials said the two projects were crucial to providing a source of fresh water to the kingdom, which faces a severe water deficit, and to reviving the shrinking Dead Sea.
Israel, Jordan, and the Palestinian Authority will sign an agreement with the World Bank, opening the multi-billion-dollar project to an international tender. Proponents like Silvan Shalom, the Minister for Energy and Water, say it would stabilize the Dead Sea level, supply drinking water in the region, and strengthen regional cooperation. The idea of sending seawater to the Dead Sea has been around for decades, but feasibility studies and high estimated costs always ended up just that, an idea. But this project is different. It calls for a pipeline to be laid in the Gulf of Aqaba that will transport brine water, a byproduct from desalination plants, 180 kilometers north to the Dead Sea. The entire project will be on Jordanian territory, with freshwater pipelines stretching into Israel, and it will take about 4 years to build. The water will replenish the Dead Sea.
After we saw the video of this huge project, let's focus with some more details. In this picture, you can see the course of the pipeline, the red line. Dead Sea is the lowest point in the world. One of the biggest use of this project will use the difference of heights in order to make electricity. In this picture, you can see the difference of heights in this project. In order to use this differentiate to make electricity, it is necessary to use the stream of water to rotate a circular element, as you see in this picture. This element called turbine. You can see in this picture also an element of a turbine, but what a turbine is? A turbine is a rotary mechanical device that extracts energy from fluid flows and converts it into useful work. The work produced by a turbine can be used for generating electrical power when combined with generator, as you see in this picture, a real turbine. So the process uses a turbine, and the water goes into the turbine, as you can see here, and use the power to rotate the turbine wings and to light the light here. But can we use salt water of the sea for this purpose?
Go.
Hi everyone! We're talking about the project of Red Sea to Dead Sea. We're talking about how to make an energy out of the pipeline that is going to bring water from the Red Sea to the Dead Sea. We saw the course of the line, we saw the heights between the Red Sea and the Dead Sea. Now we need to take a turbine and to put the water into it in order to make the energy. But the water is made of salt water. And what will happen if the salty water will go into turbine? We will have this one. We see a corrosion. So in order to prevent a corrosion, what we need is a water without the salt. So we need to make the water without the salt. How do we do this? We're going to do a boiling point. So now we will talk about the boiling point. Thank you.
So now we are in technical chemistry lab, and I will explain to you what is boiling point. Boiling point is a parameter of a material or a substance. Boiling point is a temperature when one material change from liquid to vapor, and that temperature is the boil point of that material. Just like you see in the laboratory, the water, pure water in the bottom is boiling, and the temperature now in the water is boil point. Okay, now we are on the top of a mountain. The altitude of the mountain is 2,000 meters. So the altitude of the mountain changes, and then the pressure here is changed. It's different from just in the technical chemistry lab. So the boil point will also change in here. So we do the same experiments on the top of the mountain, and then the boil point will change. So now the boil point of the water will decline into about 90 degrees. At the same time, the pressure is one factor that influences the boil point of water, and we also have another parameter to influence the boil point of water. Okay, that is all about boil points. So now let's move back to our home, and I will teach you how to do a small experiment to understand the boiling point. Okay, let's go.
So now I want to do a small experiment which we can do in our daily life to prove what I already introduced before. Now I got some stuff: spoon, the water from the tap directly, and salt, and the pot. So I put a small spoon of salt into the water and fix it to make a homogeneous solution. So you see. What's your feeling, Jessie?
It's a little salty.
The salty water. Let's put it into the pot. Because it's a homogeneous solution, so it doesn't matter how many is left. Now we put it into the on the heater and heat it now. After 10 minutes, let we have a look at the water.
It's very, very salty.
So you say after boiling the salt water, we can the steam of water can come out from the solution, and the salt remains. It means that the boiling point of these two different particles are different. That's the reason why we can use this method to get fresh water from the salt water to, like in the Dead Sea, to be used in the electricity power fields. So this experiment tells us that the two boiling points of the articles are different. That's the reason why the steam of water can come out earlier, and you can taste a saltier water. So we can use it and to get fresh water from the salt water in that sea and for the power fields. Okay, now my group member will introduce the usage of daily life for this boiling point.
As we mentioned before, the usage of boiling point is everywhere in our daily life. So now I'm going to give you some examples.
Antifreeze helps prevent the water in your vehicle's radiator from freezing through the freezing point depression. But you may not have realized that it also elevates the boiling point of the fluid as well. By raising the boiling point, it helps to protect against the boilovers. Many brands of antifreeze will list both the amount of boilover protection and the freeze-off protection offered. Cooking. Adding salt to water before or while heating it will increase its boiling point, so the water will actually be hotter than it would otherwise be when it comes to a boil. The amount of this increase, however, is quite negligible at low salt concentrations. Nevertheless, cooking is one use of boiling point elevation. It's also important to note that adding salt to water will not make it boil faster, quite on the contrary. Boiling point evaluation depends on the identity of the solvent and the concentration of solute particles, but not the identity of the solute. Consequently, just like freezing point depression, boiling point evaluation can be used to determine the molar mass of a solute.
Okay everyone, so today we learned the concept of boiling point. So at the beginning, we find a very severe problem at the Dead Sea, is that the sea level is dropping down. So in order to prevent this, we have to pump water from the Red Sea to the Dead Sea. And during this process, we can generate electricity from turbines. But in order to prevent the corrosion of the turbine blade, so we have to purify the water. And during the purified process, we have to boil in the water to make it more pure. And from here, we learn the concept of boiling point. After that, we learned in the lab about the physical meaning or the physical definition of boiling point. And we learned that with the change in pressure, the boiling point will also change. And after that, we did a very simple experiment, which you can also do at your home, and try it. And in that way, you will see the evaporation of water, and also to learn more directly about the boiling point. Also, you can taste it to see whether the water became more salty after boiling. And after that, we take a look at the outside world. So as you can see here, like all the cars here, so we're using the concept of boiling point every day. So the antifreeze in the car, right in the engine, it's used to cool down. But during this process, we have to prevent the phenomenon of overboiling. And also during our daily life, like cooking and professional knowledge, like in chemistry classes, we all use the concept of boiling point. So to now, our lesson is finished. So I hope you enjoy the video and have an in-depth understanding of the boiling point. Thank you very much.